Hi, it's going to be very simple recording of a example that we built for two use cases. So we're going to DistilX website and we're going to our production deployment system. And the first example, it's a car dealership use case. So in this example, we're going to work with data for retail online car sales. So let's start from explaining what's happening. There's three components in my screen. Chat on the left, specifically designed to be deterministic and verifiable. Middle control is the basically our implementation of spreadsheet. Difference between this and Excel, that we're using different language, and that it works with billion rows, million columns, and is scalable. And then there's basically our formula language. We call it DistilX formula language, or DFL, window on the right. And all of them are associative. So let's go to the first prompt and ask the question. Please describe the data, every column, and please do not do anything. And in this data set, we got 4 columns, 4 tables. It says that we built it for used car dealership marketplace. This table with dealers, we call them dealer ID, name, and state. There's 1,000 dealers. Then there's close to 100,000 listings, and it's a model, and a year, and a price. Then there's the views, 3 million views. What user, what listing, and what date, and sales. And now let's go to look at a simple scenario. I'll go through session, which we call playback, so I don't have to type my prompts. So the first question, what's the average amount of daily leads a dealer in Massachusetts gets? And system goes and does it and computes its dashboard. And the answer is 273 days, right? And the Claude would do the same. It could compute this number, but how? How do you find this number? And this is the difference. So the solution plan, we call it sometimes chain of thoughts. Sometimes we call it reasoning spine. So it says, first, I need to identify all dealers in Massachusetts. And I'm going to create a table called selected dealers. And it's the formula. Filter all dealers in such a way that actual state equals the value of this state control. So system anticipated there's going to be different potential states and create this control for me. So if I go to Colorado, the answer is different. And if I go to Arizona, then it's different. And Massachusetts is, as we know, 273. Next is going to say, well, go selected listings and select only listings from Massachusetts. And it goes and says, filter all listings in such a way that all the dealers are in the list of selected listings. And then it goes to selected leads and finally gives the average. So the first question is easy. Second, what model of a car has the highest lead conversion? Here's the interesting story. You can do lead conversion absolute or relative. And I do relative, and it computes it, and it tells me that for each car, for Toyota RAV, this all the leads, this all of them right here. The table in DistilX can have cell, can be another table. And then it says, well, what is the leads? Count all the leads in the views, count all the sales in the sales, and conversion. It's basically sales divided by leads. And based upon that, the highest is Toyota Tacoma, and we're getting exactly this answer. Third prompt is more difficult. How many days it will take to sell Ford 50 price of 30K? And this is it. System goes, comes up with interesting statistical analysis. Says, first of all, give me all 150 sales, then summary statistics, and the formula, which is really of interest to us, is this one. It basically says that filter all the sales of 150 at price between 27 and 33,000. So it basically assigns some boundary, computes how many days going to sell every car in this price range, and then computes average of this. It's kind of interesting method of solving this problem. And I like this algorithm, it's a statistical algorithm. And so system, I said, hey, you know what? I like this so much, this algorithm, that I want to create a dashboard. Do me a dashboard which repeats it for any car, and it does it for me. So it creates this solution. So here is a make of a car, and in Texas, it's basically going to take 39 days. If I go right now to Massachusetts, we know it's going to be 43 days. And so now I like the solution so much that I'm creating what we call endpoint. Endpoint, it's the publishing this on the server. And if I go here, this is my predict car sell for endpoint, and this is my prediction control, and this is my statistic. And I try it, and I basically say to system, you know what, take this endpoint and build for me in base 44 application, how fast your car will sell. And I just build this application. I'm saying that Ford 150 or 23, select state is Massachusetts at $30,000. I'm going to take API key. I need to insert this key here. And we see that predicted to sales 43 days. And if I change the state, or I change the price, it's basically going to work fantastically. It's a statistical analysis. So this example of car dealership, there's another example I quickly show, bank loans, similar application credits, where here we are following the following script, which is going and asking system first, describe data and is data consistent or not. And we're seeing right now that consistency of data is determined that, for example, it finds that status field is status column has some strange values A and F, which are wrong. And it basically tells us custom ID and everything. So data is not consistent. I'm asking it to fix the data. It asks me how I'm going to do it. I'm saying I'd like to drop all the inconsistencies. And it basically tells me, first, I'm going to clean custom records. Then I'm going to clean create profiles. And then I'm going to remove duplicate loans. Eventually, it creates for me all the summary and cleans the data in special clean data set. And final prompt would be interesting. I want to follow in research. I want to classify all loans by profession and predict what professions the default rate would be highest and create a dashboard for me. And the system does all the analysis and decided to use XGBoost training model, and it created trained data and literally scored every loan for default rate and built dashboard for us. And this dashboard has this columns. And then I created a sensitivity study, which was very simple. And I analyzed the sensitivity of loans for being defaulted. And eventually I built similar application here, sensor create sensitivity study for what profession the loan would be, what the impact of default probability change for what profession. I just run the sensitivity study. So what we've seen ability to build applications using language, validate them in the formula language, run reports, and deploy it in production. And so that's the end of my presentation. Thank you.